Hi, my name is Thomas Kim. In this session, we will learn how to implement Boolean expression. Boolean expressions will enable us to implement loop if in our future sessions. To follow this session continues from our previous session. Please watch this video, YouTube video, and download source code. By clicking this download link, source code will be downloaded. Also understand that to better understand, you probably need to watch my other videos about the string conversion. When the solution is downloaded, then please unzip it. Then copy the solution. Inside the solution, copy this solution, this file, then copy to your working folder. Control F5 for test. If you have problem building this solution, if you have error message while building solution, you probably have to make proper settings for Bison and Flex. You have to install Bison and Flex on your machine to properly build this solution. If you fail to compile, then please watch my previous videos about how to set up Bison and Flex on Windows platform. Also leave comments, then I will try to answer you back. From our previous solution, I will make in Solution Explorer source file, I will make a few changes here. Scroll down here. I made very stupid thing. I did say this is actually redundant, so I will change it, I will fix it like this. Since this is W string, we can say std w wo string wos like this. Then WOS P result. We use this operator to convert P result to string. We need header file here. Include string. We have to include this header file. Then back here. Then OS, we are putting out WOS. Then str. We can actually do this. So the reason it works is that I already defined operator. This is W string. This, let's see, W string to stream operator. I already defined this function in my previous video in different series, so it works. About this string conversion, please watch my other videos about string conversion. Okay, now Control F7 to compile this file only. Okay, it works. Then later, if we update this function, then it will be automatically handled properly. Now we are implementing regular. Please open Bison parser y, this Bison file, Bison info file. We are now implementing Boolean type. Let's try with like this. bool. I will tag it blen. Blen means Boolean, because if I do Boolean it would be too long, so I want to make it short like this. Blen, blend. Okay, add this one. Then we need to define here. I will define one token, token. I will define token later. Here, type blen expr blen intg, like this. Blen intg. Blen intg means we are defining Boolean expression for integer type. Then here we need to add one expr blen intg, like this. Now we define Boolean expressions. Boolean expression expr boolean intg, like this. Then expr intg, then less than expr intg. We have to define operator precedence here. It takes higher precedence, it takes lower precedence, then we need another operator. We define two operators, greater than, less than, greater than. Then here now copy this code, this text. I will align. It should be greater and it should be greater, like this. Then semicolon, save. Then Ctrl F7. Okay, you should not have a shift reduce or reduce conflict. You should have no warnings. Okay, it should build cleanly. Then we will implement another one here. Please watch carefully how I implement blen dble. Dble means double. Okay, this is also Boolean expression, so here I copy. It will be dble, then I copy it like this, then dble. Now we are comparing two double values, dble. dble is expression we defined in our previous video, dble expressions. Copy. Save. Now build again. Ctrl F7. You should not have any warnings here. Now everything seems to be working fine. Now we need to implement another thing. Now add one more blen and also token. token. blen means Boolean. lit blen. See, I'll say bool, like this. I will also remove literal here. I will just int, integer, double. Okay, I fixed like this. Then we don't need this. We will introduce another one here. blen Now we remove. Then here blen becomes expr, blen becomes expr, blen intz. Okay, or it can also be expr, blen dble. And one thing more, lit, literal boolean, blen. Okay, now save and compile. Control F7. We should not have any warning message. Okay, we don't have warning message. Okay, I will build. Is this program, this state still have problems, but I will let you know later. Now, so we added the Boolean expression. We have to update this function too. Click this, save all, then class view. If you have watched my previous videos in sequence, you may understand what I'm doing. Now, here we will find pushback. Just click this, and sorry, I will click once again. See parser manager here, and pushback. I will say pushback boolean. Pushback blen. Blen means boolean value, so it should be bool value. Save it. We saved it. Then here double click it. Then here pushback double. Okay, here we are copying the code. If you watched my previous video, you will understand. blen bool, then it should be blen, and it should be blen. Okay, now save. Now build the solution. Solution should build successfully. lib parser. I just build only lib parser. Okay. Now in Lexer, please select the Lexer file here. Open Lexer. We need to add operator. Two operator here. In operator specification here, we need to add less than, greater than. We need to add two more operators. Then rebuild. Select this file, lib parser once again here. We also need to update this file here. We need to incorporate here. It should be blen, boolean data type, and std bool alpha, like this. Then it should be blen, boolean value. Okay, I will create one more function. Copy the we copy this text. Copy this one. Copy. Then paste it here. Okay, now I will change the name of the function like this. Type to WSTR. Okay, then remove this part. Here std string WOS. I will say OS here. Now we are printing the type. Okay, so this type is integer. I will say int. Then L. Then this type is double. And this type is Boolean, bool. Save it. Also, once again, we copy it. Now it should be, no, I made a mistake. I made it here. We are making it to string. W, string. Okay, we make like this, and it should be str. We should pick like this, and here string, and type to string. Okay, then we can simply return like this, type to W string p result. Then we say to str. Okay, done. Save it. About these string manipulation functions, I already explained in my previous video, in other videos. So I will put the link in the comment description section. Please leave it to my other video about these string conversions. I save them, and okay. Now let's go here. Type editor. Select class. No, before we move on, let's rebuild lib parser. Right click it, build only lib parser. Sorry, I forgot one thing. Here in header file, I forgot to add two more. I added two more functions, so I have to add them here, like this, and one more. Okay, now it will work. Save. In class view, code editor view, on command, on cmd run in process here. Now scroll down. I will change it to easier way, auto p result. If you watched my previous video, you understand what I'm doing. Like this. Then we can simply put p result. P result. We can simply put p result here. Then instead of doing this, we can say put a space like this. Then to type to W str. Okay, p result. Okay, we are actually using this function we defined here. Type to WSTR. We are using this function here. Okay, now build. Control F5. Okay, we will load our previous sample. So if you don't have previous, I will run it first. Then it will be displayed like this. Then if you don't have this sample code, you will actually have sample code in the. I put in the release folder, I put sample code, sample1 code here. Then you can try with this one, run process. So it runs, this is double, this is int, everything runs properly. Now we can test the Boolean value, 5 is greater than 4, okay? 6 is less than 4. We are testing. Now let's run. Sorry, it doesn't work. What's the problem? Let's check what's the problem. Oh, I forgot to add here. We have to put in parser y, we have to put the result like this. Push back result blen $1. Now build and run again. Control F5. Okay, let's run. Okay, true. 5 is greater than 4, true. 6 is less than 4, false. Then let's try this one. 5.6, 4. 5 less than 6 points, like this. Now let's try. It will give us error message. See, syntax error. See, the reason this becomes syntax error is that this is real type, double type, this is integer type. So we have to resolve this issue. To resolve that issue, we have to introduce another one, another expression. Here I will make it like this. Type blen. I will copy it. Then expr blen dbnt. See, dbnt, we made it. Now this is a boolean, expr boolean dbnt. Now we copy it. No, we don't need to copy it. Say we need to make we need to define expr blen dbnt. Here we copy this code like this, copy and paste. Then here it should be int. We are comparing intg, integer, with double, and intg, double. Okay, then here we are comparing intg, double, intg, double. Then we made all how can I say, combinations. So integer double less than is compared here, double integer is less than is compared here. So this way, then we have to add here expr blen dbnt, like this. Save it. Now Control F7. We should not have any warning messages here. Now Control F5 to build and run the solution. Okay, load our sample. Now let's run. Now it runs successfully. All these combinations can be resolved successfully. Now close it. We need to implement another thing. Say this is greater than, less than. Then what about equal? We will implement equal and not equal, greater than or equal to, less than or equal to, these more complex Boolean operators in next session. Thank you for watching.